For as long as humans have looked into mirrors, we have viewed aging as an inevitable slide into the grave, a biological tax that every living thing must pay. We've treated wrinkles, gray hair, and failing knees as the natural order. But as we stand here in 2026, the scientific community is beginning to whisper something revolutionary. Aging isn't a law of physics. It's a software error. It's a buildup of cellular trash. And for the first time in human history, we aren't just watching the clock. We are learning how to reach inside and move the hands back. To understand how we fight aging today, we have to look past the skin and deep into the code. This brings us to the first breakthrough of 2026, the epigenetic clock. Think of your DNA as a massive library of instructions. When you're young, the books are open, clean, and easy to read. But as time passes, the library gets messy. Dust settles on the pages. Bookmarks are misplaced. This is epigenetic noise. By 2026, our diagnostic tools, like the improved Horvath clock, can measure this noise with terrifying precision. We can now tell you not just how many birthdays you've had, but exactly how much biological mileage is on your heart, your liver, and your brain. In 2026, your biological age is the only number that actually matters. If you are 40, but your epigenetic clock reads 55, you are a ticking time bomb. But the magic of 2026 is that this clock is no longer a one-way street. This leads us to the front line of the war, the Great Cleanup, also known as Senolytics. Inside your body right now are zombie cells. Scientifically, they are called senescent cells. These are cells that should have died, but they refused to leave. They sit there, stopped in time, pumping out inflammatory signals that infect healthy cells around them. They are the primary reason we feel old. In 2026, the first large-scale human trials for senolytic cocktails have finally matured. We aren't just suppressing symptoms anymore. We are sending in a biological hit squad to identify these zombies and force them to complete their death cycle. The results of the 2026 trials are staggering. By clearing the cellular trash, we aren't just stopping the clock. We are rejuvenating the tissue. It's like cleaning the soot out of an engine and watching it run like new. But perhaps the most ambitious project of 2026 involves partial cellular reprogramming. Inspired by the Nobel-winning Yamanaka factors, scientists are now testing ways to reset a cell's identity without turning it into a stem cell. We are essentially telling an old, tired skin cell or a failing heart cell to remember what it was like to be 20 again. It is a delicate dance. Push too hard and you get cancer. Push just enough and you get regeneration. In 2026, we have moved from mice to the first highly controlled primate trials. We are seeing blind eyes see again and scarred hearts heal. We are learning to speak the language of the cell, and the message we are sending is restart. Dr. Keeler leans over a sketch of a human hourglass, but instead of sand falling down, some of the grains are mysteriously floating back upward. The diagnosis for 2026, he whispers, his pencil scratching against the paper. We've realized that the body isn't a fading photograph. It's a self-repairing machine that simply forgot how to fix itself. We are finally giving it the manual. We aren't chasing immortality. That's a fool's errand. We are chasing Healthspan,
A world where a 90-year-old has the biology of a 50-year-old. A world where the end comes quickly and cleanly, rather than through decades of slow decay. He draws a final, sharp line through the word inevitable. In 2026, aging is no longer a mystery we endure. It is a technical challenge we are solving. The clock is still ticking, yes, but for the first time in history, we found the key.